Hi, everybody. Welcome to Math 60. We are covering section 3.2 in this video, and that is plotting, also known as graphing equations. And we're going to stick with linear equations for now, but what we're really doing here is we're practicing changing representations. So I've talked about these four most common representations, pictures. And when we graph an equation, we start with a symbol like 3x minus 5, and we want to get to a picture. We want to get to a graph. But most of the time that we do this, we're going to be working through numbers first and then over to the pictures. Because in the last section, we practiced going from ordered pairs like xy equals 1, -2 over to a picture 1, -2 right there. All right, so we've already practiced that point or that skill. And so when we have to go from a formula and somehow make a graph of it, let's work through the numbers representation to make our job easier. So I'll show you how to do that. Actually, I did just show you. I picked a number 1, -2. That happens to be true in this equation. Sorry, I didn't do the equation part. There we go. Y equals 3x minus 5. This coordinate pair, this ordered pair, is a solution to this equation, and so I plotted it on the graph. But in general, our numbers representation, we want to organize it in a table where we pick different x values and we find out what our different y values are. And those are going to give us the coordinate pairs for graphing. So it's always a good idea to start with the simplest x value, which is 0. And that means y is 3 times 0 minus 5, which is just minus 5. So we have the coordinate pair xy equals 0 minus 5. Let's pick another number. Oh, well, yeah, we could hop over here and we could graph that. 1, 2, 3, 4, 5. It's all the way down here. Kind of cut that off, but there it is. This is the coordinate point xy equals 0 minus 5. Notice that the x value is 0 and it's on my y-axis. This point is called the y-intercept because it's where the equation will eventually cross or intercept the y-axis. All right, 1 gives us y equals 3 times 1 minus 5, which is 3 minus 5, which is -2. There we go. X equals 1, y equals -2. There's that point right there. And let me just do another point. 2 is a pretty easy number. 3 times 2 minus 5, that's 6 minus 5, or -1. So when x is, +1. So when x is 2, y is +1. And as soon as you got 3 points, you can see, even with 2 points, you can assume for these types of equations, but with 3 points, you can see that this should be a straight line. And probably, even if I try to point in the middle, like, let's try x is 1.5. Y is 3 times 1.5 minus 5, which is, 4.5 minus 5, which is -0.5. And so when x is 1.5, y right there, more or less, is at negative 0.5. Right, so we could fill in our line with lots more points, but usually a couple is enough to get the idea. We had to graph. We went from the symbols to the pictures, but we did it by developing a table by using our numbers representation, so we could use that Cartesian coordinates plotting ability that you've been working on in the previous section. And that's really it. That's about all there is for this section, because it's basically an extension of the previous section. Instead of plotting one point at a time, we have to generate our points using the formula. So let me do another example. This time, yeah, let's do the following. Let's see. 2x minus 4y equals 12. This is an equation and we want to graph that. And the first thing I would say is, well, I think I want to solve this for y, because that's what I did in the previous equation. So I want to make this look similar. So the first thing I'm going to do is solve for y, and that's a skill we practiced in chapter 2. Get all the y's by themselves. So to do that, subtract 2x from both sides. And we have minus 4y equals negative 2x plus 12. And then let's isolate the y by dividing both sides by negative 4. And we have to divide all these terms by negative 4. And we get y equals negative 1/2 x minus 3. So this initial equation, 2x minus 4y equals 12, describes the exact same line that y equals negative 1/2 x minus 3 describes. So let's graph this, but as we graph it, we're going to use numerical representation to help us. X, y equals negative 1/2 x minus 3. So let me start with the simplest number, which is 0. And when x is 0, negative 1/2 x drops out and y is negative 3. There's my y-intercept. Always a good coordinate point to start with. So when x is 0, y is negative 3 right there. Let me try 1. That's negative 1/2 times 1 minus 3, which is, let's see, that's just negative 1/2 minus 3, which is, do some fraction work, or maybe convert that to a decimal, negative 0.5 minus 3, which is negative 3.5. So when x is 1, it looks like I came down here to negative 3.5. Okay. Just by this picture, I have a feeling if I keep going, I'm going to go down and run out of the page. So let me just put a different number. Instead of putting 2 in, I'm going to put negative 1 in. Negative 1/2 times negative 1 minus 3. That's positive 0.5 minus 3, which is negative 2.5. Aha, yeah, so I'm starting to move up and to the left. So maybe putting negative x values in is going to be a little more useful as I try to graph this equation. Negative 1/2 times negative 2 minus 3 is 1 minus 3, which is negative 2. Right, there's x is minus 2, and y is also minus 2. So I'm right here. And now I can see that this is definitely a line, and it looks like every time I walk over one x, I walk down half of a y. Or if I walk over two x's, I walk down a whole y. So I'm going to get something that looks like this. And I've gone from my initial formula, 2x minus 4y. I did a little bit of symbol manipulation, so it would be easier to generate my numbers, and then I used my numbers to draw a graph. Let's use that same formula, 2x minus 4y equals 12. And I can ask, is the coordinate point xy equal to -6, 0 on the graph of this equation? That's fairly easy to test because all I have to do is plug it in. X is supposed to be -2, y is supposed to be 0, and hopefully that's going to equal 12. If it is, it means it's going to be there on the graph of the equation. -2 times -6 is +12. -4 times 0 is 0, so it goes away. Yes, that is true, so it is on the graph of the equation. Is xy equal, let's see, -7, 4 on the graph of the equation? Visually, if you have the line, it would be really easy to see. So let's just redraw it really quick. Okay, I have it over here. I'm not going to bring it into the field of view. There it is. Notice that point right there has a coordinates xy equals -6, 0. It's on the graph. How about -7, 4? Well, that's this point right here. Yeah, that point is definitely not on the graph. It's nowhere on the line. It's never going to be on the line. So I know my answer to this question is xy equal -7, 4 on the graph. I can tell you just from my picture that the answer is no. And this visual representation is a great way to figure out these types of questions. And I encourage you to use that visual representation when you can. But if you don't, it's not so bad. You just plug your numbers in and you do the arithmetic. 2 times -7 is -14. -4 times 4 is -16. Put them together, I get -30. Is that equal to 12? Nope. Okay, so clearly those 2 points does not make my equation true. And if those 2 points don't make it true, that means those two x and y values are not on the graph of the equation. All right, that wraps it up for this video. Check back for the next one. Thanks.